Hello, geometry students. Here we're going to do a quick check on lesson 3.3. And so let me turn on my tool here. All right. So we're looking for the slope of the line containing the point -3, 4 and 5, -8. So we're going to take 4 minus -8, or 4 plus 8, and divide that by -3 minus 5. So I get 12 on top and -8 on the bottom. Divide by top and bottom by, looks like 4, and I get -3/2. So we have an answer of -3/2. Slope of the line perpendicular. Here we're looking for the slope at line perpendicular to MN. Since my slope was -3/2 in my last example, and a slope perpendicular would be the opposite reciprocal. So opposite means opposite sign. So we have positive, and reciprocal is 2/3. So we have an answer of 2/3. Slope of the line parallel to MN. Slope of the line that are parallel have the same slope. So the answer has to be -3/2. Now we're going to graph a line that has slope 4 and contains the point 1, 2. Well, slopes are of +4, so this one here has a negative slope, so that can't be right, and same here. Okay, and if you look at these two lines over here, this one here, if you go 1, 2, 3, 4, down 4 over 1, that would be a slope of 4. So the answer is A. What is the graph of the line that has a slope of 0? Well, slopes of 0 are horizontal lines, so the answer is C. Okay, here we want to be perpendicular to a line that has slope 2/3. So we're looking for a slope to be -3/2. We have one ordered pair, 1, 0. We have to find the other ordered pair that would give me a -3/2 slope. So think about what we have to do here. We need somehow our -3/2 to equal the slope between an ordered pair called 1, 0, right? And so we would have to have something that would say the difference in the y's. So we'd say something like maybe 0 minus y, right? 0 minus y over the 1 minus x would have to be a slope of -3/2. So this gives us some type of relationship here that when we put these numbers in here, right, at least we can say that we have a -y over a 1 minus x. At least we have some way to check it. So think about what values would go here to give me a -3/2, and if you notice, it would be B, wouldn't it? You put 3 in on top, you get -3. -1 on the bottom for the x gives me then a +2. Okay, in section 3.3 we found the slopes of lines, and now we're going to write an equation of a line given information about the graph. And we're also going to solve problems by writing equations. New vocabulary: slope-intercept form and point-slope form. Slope-intercept form is y equals mx plus b. So we have an actual slope times the x, and then we just add on the y-intercept. Point-slope form, you take a point and a slope, and you simply put it in the equation y minus y1 equals slope m times quantity x minus x1. So here we go. Example 1, we're going to write an equation in slope-intercept form. So that's y equals mx plus b. That has a slope of 6 and a y-intercept of -3. This is going to be a very easy question. Slope of 6 and a y-intercept of -3. Now we're also going to plot this. We're going to plot at -3 and slope of 6. So 1, 2, 3, 4, 5, 6 over 1. So we plot our point, we go up and over, up 6 over 1, and then we connect it with our line. Check your progress. You're going to write an equation in slope-intercept form of the line with slope -1 and a y-intercept of 4. And I'll pause the video. The answer is y equals -x plus 4. Here we're going to write an equation in slope-intercept form, point-slope form, of the line whose slope is -3/5 and contains the point -10/8. So, point-slope form, y minus y1 equals slope times x minus x1. So we have y minus the y-coordinate. The y-coordinate's 8. And then we have slope of -3/5. And then x minus x1. But since my x1 is -10, we'll say x minus -10 or x plus 10. And then we're going to graph the given point. So we're going to graph -10/8. So we're going to just scale this by 2's. So we're going to graph a point over here. Okay? And then we're going to use our slope of -3/5. So we can either use these are all 2's, each one line's 2. So we could go down 1 over 2.5. Or down 3, which is down 1.5 over 2.5, which puts me about right here. Or we can just go down 3, 1, 2, 3 over 5. 1, 2, 3, 4, 5. Either way, we'll just draw our line in and it connects all 3. Okay, check your progress. Here we're going to have you pause your video, and you're going to write an equation in point-slope form of the line whose slope is 1/3 and contains 6, -3. And the answer is B. We're going to write an equation in slope-intercept form for a line containing 4, 9 and -2, 0. So we're going to first find the slope of the line. So we're going to go like 0 minus 9 over -2 minus 4. And so we get -9 over -6, or reduce that down to 3/2. And then we're going to pick one of the points, either point. So we're going to use 4, 9, and we're going to use point-slope form to help us solve this for the slope-intercept form. So we'll put the point-slope form, and then we're going to use the distributive property on the quantity here, 3/2 x minus 12 over 2, or minus 6, and then we're going to add our 9. So final answer is y equals 3/2 x plus 3. Okay, here we're going to write an equation slope-intercept form. So that's y equals mx plus b is our final form. And we're going to have 3 minus -7, or 3 plus 7 on top, and then -1 plus 3 on the bottom. Looks like I'm going to have 10 on top and 2 on the bottom, or a slope of 5. Then we're going to use our value of 5 with one of the points, and this time we'll use -1, 3. And we'll put it in point-slope form, and we use our distributive property, and we get 5x plus 5, and we'll add our 3 to the right-hand side, and we end up with 5x plus 8 as my final answer. All right, so here is a problem for you to try. So pause your video, write an equation in slope-intercept form for a line containing 3, 2 and 6, 8. Go ahead and pause your video. The answer is y equals 2x minus 4. Okay, check your progress. Go ahead and pause your video. We're going to write an equation in slope-intercept form for a line containing 1, 1 and 4, 10. Pause your video. Answer is y equals 3x minus 2. Horizontal lines. Horizontal line equations, we're putting this in slope-intercept form, y equals mx plus b. If you recall from the previous lesson, slope of a horizontal line is 0. So we have a nice little thing that this will just be y equals b. Well, the y equals b is a y value, so therefore the common y value is negative 2. Therefore, my equation for a horizontal line is just y equals a number. In this case, y equals negative 2. Okay, check your progress. We're going to write an equation of a line through negative 4, negative 8, and negative 1, negative 6 in slope-intercept form. Go ahead and pause your video and try this problem. And the answer is y equals negative 2/3 x plus 4. Horizontal and vertical line equations, key concept. All right, so the horizontal line is always in the form y equals b. Example, y equals negative 3. And we also have an example of a vertical line, x equals a. Okay, so we have our vertical line here, and we have our horizontal line there. Notice that in the vertical line, remember the vertical line will be a slope that's undefined. So we're not going to say y equals mx plus b. And in this case, there is no m because a slope of a horizontal line is 0. So we're going to write an equation in slope-intercept form for a line perpendicular to the line 1/5 x plus 2 through 2, 0. All right, so we know that lines that are perpendicular have to have negative reciprocal slopes. So negative 5 is going to be my slope that I need, and 2, 0 is my point. And we're putting this in slope-intercept form. So here we go. We're going to say y minus 0 is equal to negative 5 times x minus 2. And then we're going to use the distributive property and then solve for y. So we end up with 5x plus 10. Check your progress. You're going to write an equation in slope-intercept form for a line perpendicular to the line y equals 1/3 x plus 2. Perpendicular, remember, you would use a negative reciprocal slope. In this case, a slope of negative 3. Go ahead and pause your video. The answer is y equals negative 3x plus 8. Anytime you're given a point like this where the x-coordinate is 0, then this point here is always the y-intercept. So it's pretty much a shortcut. And so there it is. All right, we have a real-world example. We're going to write a linear equation. Rental cost, an apartment complex charges $525 per month plus a $750 annual maintenance fee. We're going to write an equation that represents the total first year's cost. A for R months of rent. So we're going to say A is equal to, and then we do have something that's going up every month. It's $525 per month. So we're going to have $525 times my R for months. I'm not sure why they didn't use M, but R for months. But then we have to tack on a maintenance fee one time only, and plus $750. So for each rent, the cost increases by $525. So we have MR plus B. There's my two numbers, and then we put it in. Okay, part B. Compare this rental cost to a complex where it charges $200 annual maintenance fee, but $600 per month. So we're going to have an equation, A equals $600 per month, $600 plus a maintenance fee of only $200. So evaluate each equation for r equals 12. First complex, we're going to put in 12, and second complex, we're going to put in 12. And when I do so, I get 7,050 and 7,400. So it looks like it's cheaper for the first complex. Okay, a car rental company charges $25 per day plus a $100 deposit. Write an equation to represent the total cost C for D days of use. Go ahead and pause your video. There you go. C equals 25D plus 100. Okay. Compare this rental cost to a company vehicle charges $50 deposit but $35 per day. If a person expects to rent a car for 9 days, which company offers the better rate? Pause your video and try this question. It looks like the first company has a better rate.